Hello Jammers, I'm going to explain here how the Polkadot virtual machine works. If you look at the gray paper, all the formulas here on Appendix A define the Polkadot virtual machine. And it's quite extensive, very complicated formulas to understand, but everything is here. And to make it easier to understand, I'm going to simulate a program running on this machine. There are many different instructions that can happen, but this program is very simple and you understand how the machine works. So let's get started. This program is a very simple Fibonacci sum. So the idea here is to sum numbers using the Fibonacci sequence. Remember the Fibonacci sequence, something like 1, 2, 3, 5, 8, and 13. So basically each number is the first two numbers is 1, and then you have 2, you have 1 actually 1 and then 1. These are the first two numbers, define it, and then you have sum two numbers, get the next one. Sum 1 and 1, you get 2. Sum 1 and 2, you get 3, and so on. So this is how to calculate Fibonacci using the Polkadot virtual machine. First, you have the load instruction. What does the load instruction does? It puts some specific number in a specific register. So the Polkadot virtual machine has 13 registers numbered from 0 to 12. So the registers are basically kind of memory, but it's not a memory. It's a position close to the CPU where you can apply some kind of operation like sum or copy this value to memory. So here is the real memory of the machine, and it's a lot bigger than you can store a lot of information here. So it's a huge space where you can store information in the machine. And here are just the registers. There are just 13. So you have very limited amount of things that you can do with registers. So usually a program do some very simple stuff in the register, and when it wants to record this value somewhere, it uses the memory. But this program is very simple. It doesn't use the memory. It uses only the registers. So basically the first instruction says load the value 1. So I'm going to run the program first. So if I run the program, you're going to see it's running, and then it finishes very quick, and then the end result is 55 because it iterates 9 times. It starts with it's an iteration that goes 9 times, and so basically if you go on this sequence, you're gonna see that is Fibonacci, the ninth element of the Fibonacci sequence. So 21, 34, and 55. So this would be the final answer. Okay, so let's run it again now step by step. The first step, load 1 into register 8. Okay, so I give a step, and then 8 has 1. Then another step, load 1 into register 9. Okay, now I have 1 here and I have 1 here. And the register 7 already has the value 9, because if you look at the code, if you look at the code, there's a pre-assignment of a value 9 to the register 7. That's why it starts with 7. But you could also add an instruction in the beginning, like load in register 7 the value 9. Could be this would be the way to add a value to a register. So again, I have 1, and then I have 1, and then I have jump. What jump does? Jumps the number that is here. So basically if you have 3 and the instruction number is 6, so I have 0, 3, 6, and then the next instruction that it goes is 9. Why? Because it's jumping 3 positions. So the current position is 6. So when I jump, I go to 9. 3 plus 3, 6 plus 3 equals 9. And then I have another instruction, which is add im64. What this instruction does, it takes the value from W7, from the register 7, and then adds the value that is here, in this case -1, so it will reduce the value 1, and we will store this value into this register, which is the register 7 as well. So basically it will take the 9, add -1, and put it on W7, so it will turn this value into 8. Basically it's counting because it's a loop. So usually when in higher level programming languages, it's a basic loop that is starting from 9 and going down to 0. Okay, so now there is this branch emm instruction. What does this instruction do? It takes the value from the register 7 and evaluates if this value is 0. If it is 0, it jumps 12 positions. So basically it will go to line 24. If the value is 0, goes to line 24. If it's not 0, just continue executing. So basically next instruction, because the value is not 0, the value is 8. And now move register 8 to position 10. So basically it will take the value that is here and it will move to here, to the 10. Basically it will move, and then now I have 1 and 1 here. Why is doing this? Because I need to add the two ones, the last two values to get the next one. So basically it will put into the it will take so this is a temporary place where you put the value of register 8. So you need to move to a temporary place because you're going to replace the value of register 8 with the next result. So basically it will take 9 and 8, 1 and 1, and it will sum into W8. So basically add 64. Takes two registers and put it in this register. So basically it adds 1 and 1 and put here. And now that's why we copied the value, because we had this temporary place where we put. And now we have to move the value to W9. Now we have this new sum, and then we have the value here. Okay, so I move 1 to 1, and it was already 1, so it didn't change. Now jump -13, which means move back to line 9, and then goes back. And then again I will reduce 1 again, and then this will go on and on. So basically it's 7, and then if it's equals 0, go to 24. It's not, so it will continue basically moving. Now it will move to here, and then we'll make the sum, and then we get 3, and then it keeps going on and on, reducing the counter. Now we have 5, now we have 8. Look at here, you keep looking here. Now we have 8, and then now we have 13, and now we have 21, and now we have 34, and now we have 55, and finally the value of register 7 is 0, and now this branch won't go on anymore because the value is 0. It will jump to line 12, and then it will move the value from W8 to W7 just to 0, and the W7, the register 7, we are zeroing the values in the register, and then it will finally finish the program, and it ends. And also there is something very interesting here also happening. There is this gas counter, which is counting for each instructions. There's a cost, and this cost is being reduced. So this is how you calculate how many gas is being spent. So these are very basic instructions. If you go to this website here, the PVM developed by fluffylabs, pvm.fluffylabs.dev, you can see other programs here, other examples of programs, and you can load your own binary if you want. But it's kind of hard to create this by hand because it's like assembly language. This is the assembly. But soon we are going to have other ways to creating programs using the Polkadot SDK, which will be a lot easier. And all the instructions are in the gray paper. You can follow and understand what are all these instructions, but obviously there's gonna be easier ways to generate programs instead of writing machine code. But it's very important to understand that this machine is a virtual machine, and it's like a normal computer. It has operations, and it has a CPU that calculates, and it has like registers and then memory positions, and you can also have storage. I didn't show how to use storage in this video, but we can see this in a later video with other examples. I hope you enjoyed this, and let me know in the comments if you like the Polkadot virtual machine, and if you want more content about this, leave in the comments. Thanks for watching.